Welcome to derivatives of inverse trig functions. So just recall if f inverse is the inverse of f, then we have the derivative of f inverse of x is 1 over f prime evaluated at f inverse of x. So if we wish to find the derivative of sine inverse of x, then we can do this. So the derivative of sine inverse of x, sine inverse, this is the inverse of sine of x. And so finding f prime of x, or the derivative of sine inverse of x, that's equivalent to doing 1 over the derivative of cosine evaluated at sine inverse of x. So, sorry, the derivative of sine. So we're going to use the fact derivative of sine is cosine of x. So the derivative of sine, again, we would do cosine. And now we should evaluate it at sine inverse of x. So essentially what I'm doing here is I'm taking g to be our sine. So we have g prime is cosine, and this is g inverse. So what I have here is g prime of g inverse of x in the denominator. At this point, we just have to do some trig manipulation. So we're going to do, oops, let me change colors. Let's do some trig manipulation. So recall sine is opposite over adjacent. So if we're looking for the angle that would give us sine of that angle equals x. Right, so if sine inverse of x equals theta, then we have that sine of theta is equal to x, or x over 1. Then if this is our angle theta, we could do that as putting x here and 1 here. So x is opposite, 1 as the hypotenuse. Sine is opposite over hypotenuse. Sorry about that. So at this point, we could then solve for the missing side. So we know that this is something squared plus x squared equals 1. And so that something would have to be the square root of 1 minus x squared. Okay, there we go. Sorry about that. So our triangle we're looking at, here's our theta, which was the sine inverse of x. Here's our x and 1. And the adjacent side is square root 1 minus x squared. So if we wish to find cosine of sine inverse of x, this is cosine of our theta. And cosine is adjacent over hypotenuse. So that would be square root 1 minus x squared over 1, or just square root 1 minus x squared. So we now know cosine of sine inverse of x is the square root of 1 minus x squared. So again, if we look at our original derivative of sine inverse was 1 over cosine of sine inverse. So if we plug back in, plugging back in, we get that the derivative of sine inverse of x is 1 over the square root of 1 minus x squared. So we could do similar trig manipulation for all of our inverse trig functions. I'm not going to do them here, but we could do essentially the same thing for each. So we just saw the derivative of sine inverse of x was 1 over the square root of 1 minus x squared. It turns out that the derivative of cosine inverse of x is just negative 1 over the square root of 1 minus x squared. Turns out the derivative of tan inverse of x is 1 over 1 plus x squared. The derivative of cotan inverse is just negative 1 over 1 plus x squared. The derivative of secant inverse and cosecant inverse are a little more complicated. Secant inverse is 1 over the absolute value of x times the square root of x squared minus 1. And the derivative of cosecant inverse is negative 1 over the absolute value of x times the square root of x squared minus 1. Again, you could solve all of these essentially in the same fashion as how we did the derivative of sine inverse of x. You would take advantage of the fact that we're working with an inverse function, find the derivative, and then you'll have a series of trig functions evaluated at inverse trig functions. And so you can use our right triangle trig and do a bit of manipulation.